Hi, hello friends, welcome to our channel Study of Mathematics. Hi friends, in this video we will discuss the problems in that exercise 3e section 2 problem number 1. The problem is if A equal to matrix 0 1 1 1 0 1 1 1 0 and B equal to half into matrix B plus C, C minus A, B minus A, C minus B, C plus A plus A minus B, and last row is B minus C, A minus C, A plus B. This is a given matrix B. Then we have to show that AB, A inverse is a diagonal matrix. AB, A inverse is a diagonal matrix. Then we'll go to solution. First write down the given matrices. Given matrices are first matrix A equal to 0 1 1 1 0 1 1 1 0 and matrix B equal to half into B plus C, C minus A, B minus A, C minus B, C plus A minus B, B minus C, A minus C, A plus B. This is given matrices. Then we have to show AB, A inverse is a diagonal matrix. Diagonal matrix meaning is that, or definition is that, diagonal matrix, the only diagonal elements or non-zero elements other than the non-diagonal elements are equal to 0. That matrix is called a diagonal matrix. Then first in this AB, A inverse, first we have to find AB. We have to multiply matrices A into B. First matrix A is 0 1 1 1 0 1 1 1 0 into matrix into half into matrix B plus C, C minus A, B minus A, C minus B, C plus A minus B, B minus C, A minus C, A plus B. First we have to multiply A into B. Then that is equal to, this is a scalar number, then it would be present in the first half into multiplication. First row, first column, 0 into B plus C, 0, plus 1 into C minus B, plus C minus B. One minute. That is equal to half into 0 into B plus C, 0, 1 into C minus B plus C minus B, plus 1 into B minus C plus B minus C. This is the first element. First row, second column, 0 plus C plus A plus A minus C. This is not a place. Then I have to multiply here also, here only. Then AB is equal to half into, yeah, we can take the multiplication. Then 0 1 1, first write down the matrix, 1 1 0 into half is placed before the matrix, B plus C, C minus A, B minus A, C minus B, C plus A minus B, B minus C, A minus C, A plus B. This is a second matrix, that is equal to half into. Then first row, first column, 0 into B plus C, 0 plus 1 into C minus A, sorry, C minus B plus B minus C. And first row, second column, 0 plus C plus A plus A minus C. First row, third column, 0 plus A minus B plus A plus B. Second row, first column, B plus C plus 0 plus B minus C. Second row, second column, C minus A plus 0 plus A minus C. Second row, third column, B minus A plus 0 plus A plus B. Third row, first column, B plus C plus C minus B plus 0. Third row, second column, C minus A plus C plus A plus 0. Third row, third column, B minus A plus A minus B plus 0. Here, plus B minus B and plus C minus C also get cancelled. Here plus C minus C get cancelled. Here plus B minus B get cancelled. Here plus C minus C get cancelled. Here plus A minus A plus C minus C get cancelled. Here minus A plus A get cancelled. Here minus B plus C get cancelled. Minus A plus A get cancelled. Minus B plus B minus A plus A get cancelled. Then this is matrix is equal to, then this multiplied matrix is equal to AB is equal to half into matrix 0, 2A, again 2A, here 2B, 0, 2B, 0, sorry 2C, 2C, here also 2C, 0. This is a multiplied matrix. AB equal to half into matrix. Here all values are cancelled, then that value is 0. Here A plus A, 2A. Here also A plus A, 2A. B plus B, 2B. All values are get cancelled, then value is 0. B plus B, 2B. C plus C, 2C. C plus C, 2C. All values get cancelled, that value equal to 0. Then we get that AB equal to half into matrix 0, 2A, 2A, 2B, 0, 2B, 2C, 2C, 0. Then this is AB value, that is equal to half into, here we get that common, from first row we take the common 2A into 2A, in second row we take the common 2B. Similarly, in third row we take the common 2C. Then the remaining matrix is 0, 1, 1, 1, 0, 1, 1, 1, 0. Here 2, 2 get cancelled. That is equal to 2 2s are 4. 4 ABC. This is AB value. 4 ABC into matrix 0, 1, 1, 1, 0, 1, 1, 1, 0 is nothing but the matrix A. Is nothing but the matrix A. Then we have AB equal to 4 ABC into matrix A. Now we can calculate AB into A inverse. That is equal to, here AB into A inverse. That is equal to, AB is nothing but 4ABC A into A inverse. That is equal to, these are the constant numbers, 4ABC into A inverse. that is nothing but 4ABC into, we know A into A inverse value is equal to identity matrix or unit matrix, that is equal to capital I, that is equal to 4ABC into capital I into means 1 0 0 0 1 0 0 0 1. This is a I value. Then 4ABC into I value is 1 0 0 0 1 0 0 0 1. Next, that is the AB A inverse value is nothing but ABC into matrix A, matrix I 1 0 0 0 1 0 0 0 1. We have to multiply ABC with each element in the matrix. Then 4ABC 0 0 0 4ABC 0 0 0 4ABC. By observing the matrix A 4ABC 0 0 0 4ABC 0 0 0 4ABC, this is a diagonal matrix because all the diagonal elements are non-zero elements, and other than the diagonal elements are equal to 0, then that matrix is called a diagonal matrix. Then we say that AB into A inverse is a diagonal matrix. Is a diagonal matrix. This is the solution of this problem. For finding this AB into A inverse is a diagonal matrix, first we have to find, we write down the matrices, given matrices A and B, and then first calculate AB value, A into B multiplication. By calculating multiplication, we get AB equal to 4ABC, constant values, 4ABC into matrix 0 1 1 1 0 1 1 1 0. Then this matrix is nothing but A, then AB equal to 4ABC into A. Now we have show AB inverse AB A inverse is a diagonal matrix. Then first we take that AB into A inverse, that is first substitute AB value. AB value is 4ABC into A. Then here A into A inverse value is nothing but I, we know I value is 1 0 0 0 1 0 0 0 1. By multiply 4ABC scalar with each element in the matrix, then AB into A inverse equal to 4ABC 0 0 0 4ABC 0 0 0 4ABC. We know that this is a diagonal matrix. This is the solution of this second section, first problem. Thank you for watching. Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.